Okay, section 7.2, we're going to do applications of solving equations. And to start, instead of like the PowerPoints, I just jotted down some of these and you have these on your paper. Keywords for addition, subtraction, multiplication, and division. So if you take a few minutes to read through those, when you have word problems, those are indicators of the operation that should be used. So sum, addition is sum, more than, plus, added to, increased by. Subtraction, so subtraction's the one that's tricky, and I would put a star by less than, because it's a turnaround word. So usually, like if it'll say 5 less than x, when you write that expression out, you're going to have the variable first. And I just call that a turnaround word. So you might want to put a little star by the less than. Minus, you read it as is in the flow of them. The rest of them are all kind of in the flow of how you read it, you write it, except for that one. Multiplication, times, multiply by, of, twice, and product. Or like if we used to know the triple of something, then you know to multiply by 3 and such. Division is keywords or quotient, divided by, and ratio. These are not the only ones, they're just probably the most common. The other thing we're going to talk about today is mixing problems, and these are just some formulas, mixing, interest, and motion problems. And you may add those 3 formulas, the mixing, the interest, and the motion, to your formula sheet. So just you're given a formula to use, and we're going to talk about how to use those to solve some. So in the very beginning, just like with most word problem things, we're just going to kind of work through some examples of these and some different ways in which you might be asked questions about them on your homework and on a test. So here's a couple examples, and you have these. But the first one is we want to write an expression that this statement has. So we have a number decreased by 12. We'll just say let x be a number. It could be n, it could be p, we could let it be any variable. We're just going to say x. So what would be an expression that represents that statement? X minus 12. A number decreased by 12. Okay. The next one says a ratio. What's ratio keyword for? Division, good. Of 25 in some non-zero number. We're just going to say x. And we'll make the comment that x cannot be 0. One of two things is because, one, division is not defined if you have 0 in the denominator, so we knew that would make it undefined. So we know by those characteristics that x couldn't be 0, but it specifically said a non-zero number, so we just make that comment out to the side that x can be anything, but it can't be 0. All right, which is not a valid translation of 30%. Of a number. 30% of a number. So what's the of tell us we're doing? Multiply. Okay. 30% of a number. Which one's not valid? So if you have 30%, if I was to rewrite 30% as a decimal, how do you go from percent to a decimal? Yeah, right. So if we were looking at it, we can either look at it at like 30% or we can look at it as 0.3. So is 0.30x equivalent? Yes, good. What about this one? Same thing, you just don't have that extra 0, but that's fine. It's the same value. 3 out of 10, that's 0.30. That's in the 10th place. That's 3 in the 10th place, and that's correct. The only one that's not is what? This is the only one that's not, but tell me why. Because it doesn't have of a number, meaning multiplied by a number, say we're calling it x in this case. Good. So some of these you'll be given multiple choice and say find an equivalent expression or find the one that does not match the statement. Okay? Now here we go with one that says, if 3 is added to a number and this sum is doubled, the result is 2 more than the number. Find the number. So this time we're actually going to have to write the expression. Then after, we're going to apply what we did in section 7.1 and solve it to find out what this number is. So let's just kind of break this down. We'll let x be a number. It says 3 is added to a number. 3 added to a number. Okay, we're pretty good there. And this sum, meaning this entire sum, is doubled. So what do I do with that? Multiply by 2. Technically, writing it again is the same thing, but we're going to multiply that thing by 2. Yeah, that actually be careful not to square it, because if you do it times itself, write it 2 times, that means squared, and squared is not the same thing as doubled, so be careful there. So we multiply by 2 to double it, and then it says that result is a key word for equals, so that's kind of where your equals come from. 2 more than, what's more than represent? Addition. More than a number. Or it's okay if you had x plus 2 over there, because addition is commutative. So here's a pretty good representation. It doesn't have to be the exact as mine every time, but pretty close. Now we're ready to solve. My left-hand side needs to be distributed. It's not simplified yet, so I'll have 6 plus 2x, 2 plus x. Now, we look at the left-hand side, it's as simplified as it gets. The right-hand side is as simplified as it gets. So now we're ready to start solving the equation process. And our objective is to get the variable by itself, meaning the first thing we have to do is get them all on the same side, or I'm going to move this x over or subtract x by doing the opposite of it so that it goes away. And now I have 2 minus 1 is just 1. And our goal is to get x by itself, so we say, what did they do? If they add 6, we do the opposite and subtract 6 from both sides. Always trying to isolate the variable. So when that cancels, you're going to get x is equal to 4 and positive. Different signs, subtract, take the sign of the larger number. So x is equal to -4. We also know that we can check. So this is going to be our equation that represents the word problem, and this is our solution, -4. Okay. Let's look at another one like that. A good bit of your problems today for the homework will be this. So taking a word problem, rewriting it as an equation, and then being able to solve that for the missing variable. Okay. If 4 is added to twice a number, and this sum is multiplied by 2. Okay, stop me if you have questions on where we're going. The result is, that's our indication for equals, the same as if the number is multiplied by 3, number multiplied by 3, and 4 is added to that product. So the product of those two, and 4 is added to that. What is the number? So always make an attempt at writing it down, then go back and kind of read over it and make sure that what you're writing down is in fact what the word problem is describing, and we'll feel pretty good about this one. So we'll go ahead and distribute this left-hand side out. Go ahead and try this part on your own and look up here just to check your answer when you get to that point, but see how far you can get solve for x. Okay. I get x equals -4. Not that -4 is always the answer, it just happened to be in these first two examples, but you want to get the left-hand side simplified, right-hand side, then your next step is to move the variables all to one side, simplify, and then get the variable by itself using inverse operations. So let's look at our next one. Boston Celtics won 2 more than 3 times as many games as they lost. They played 82 games. How many wins and how many losses? So in this one, they're talking about wins and losses. So we're going to have to pick one, and we don't know either yet. Okay, we just know relationships in respect to one another, but we don't know. We do know that total there's 82 games, but we're going to have to give these a variable. So in this case, I'm just going to say let's let x equals the number of losses. Just because the relationship described is talking about as many games as they lost, okay? So if x is the number of losses, and it says they won 2 more than 3 times as many as they lost. So if this is 3 times as many as they lost, plus how many more? 2. Now let's look at that. And this would represent what? The number of wins is represented by this. So let's read that again and make sure we're on the right page there. So we won 2 more than 3 times as they lost. So if we let x be loss, then 3 times their loss plus 2 more. So we're good there. So that's going to represent our wins. We have x to represent our losses. What's the other thing that we know?
They played 82.
82 together. So wins plus losses must equal 82. So if I have my my losses plus my wins must equal 82 total. Good. So now I can just put those two together, and we want to solve for what the x is, meaning add like terms on the left side. This thing's not ready to solve yet. We've got to add all of our like terms, and right there that's just 4x plus 2. Now we want to solve for x. So subtract 2 from each side. Divide both sides by 4. And x is equal to 20. What does 20 represent? Losses. Okay. So if I know I have 20 losses, then how can I figure out how many wins that I have?
You subtract 82 from.
Or we could do that because that's just a intuitive thing to do. Or we could even just plug into our equation up there, 3 times 20 plus 2, and see that that's 62. But you also knew this, so 62 wins. You also could figure that out by taking the 82 and subtracting the 20. Bam, done. But if it's not as easy as this, then you can plug that in and see. So good job there. This next one is just going to be a mixture problem. So you'll say base times rate is equal to the percentage. In that case, so it says how much acid is in 500 milliliters. Let's just read this equation. 500 milliliters, what's of mean to do? Multiply of 14%, but usually instead of when we're making calculations, we don't keep the percent in there, we change it to a decimal, and how do I rewrite 14%? 0.14. Or 0.14 is accurate as well. So that way when you multiply that out, you're going to get 70 milliliters. Okay. an interest problem. So if $10,000 is invested for 1 year at 2.5% simple interest, how much interest is earned? So you start with your principal amount, which is 10,000, and you invest that. So we're going to multiply that by what's the percentage? What's the decimal value of 2.5%? 0.025. Good. Just move this decimal 2 places to the left. And then you simplify that. When you multiply times thousands, if it's 4 zeros, you can move it 4 places. So if we was to move that, it would be $250. What is the, that's missing a Y, monetary amount of 497 nickels? You take 497 and multiply that times the value of a nickel, which is what? 0.05. And that's just a basic multiplication. So if you go to the side, you multiply that out, which we've done that before, decimals. We would have $24.85. So this is the application of it, like how do we set these problems up and what do we do to solve them. So some of these are pretty basic, some of them are not so much, but in a minute we're going to get to the more challenging ones, which I believe is this next problem. So pushing through the real simple ones, now we look at one like this, and this is a mixture problem. It says in chemistry, 12 liters of a 12% alcohol solution is mixed with a 20% solution to get this 14% one. How many liters of the 20% are needed to make that happen? So we're given different percentages of solutions, and we want to mix them to get a desired. And so when we do this, when we do the mixing problems, anything that gets like this, you really want to be able to set up a table. And so I'll kind of preset this up for you, and we're always going to start with what we're given, and then we're going to figure out what we need. And there's a little bit of rhyme or reason how we work this table. So, 12 liters of a 12% solution. So you can see the strength was 12%, and I went ahead and put 12. So I plugged that in because that was given to me in the first sentence. And it said, must be mixed with 20% solution. So I know another solution I need is that 20%. So I wrote the 20% one down to get a 14%. So in this table, what I did is I wrote down all the different strengths of solutions we had. They've mentioned a 12%, a 20%, and a 14. So I wrote those down. What I do know is the 12 liters of a 12% because it was given. And then what's the question? How many liters of a 20%? So that's going to be our X. So figure out your end game is what is the X? What am I looking for? So I don't know what it is, but I do know it's what I'm looking for. So I'm going to let that be my X variable. Okay. And then you probably should know something about the next one where it says when you multiply let's see, when you mix them together, you'll get a 14% solution. So what are we doing with those? With the two above. When we mix them together, so when we add them together, so what do I know about the 14%? It's just the addition of the other two, right? So, but in this case, how would I represent that? 12 plus X. I don't know what X is, but I do know I added them two together. I added them two together to get the 14%. So when you first get these, you want to write down all the strengths that are listed and try to give everything that's known. Those are the easy ones. Then identify what you're looking for. That's usually your X. And the next one's probably going to be something using that when you make something that represents it. And then from there, we'll multiply across. I'm going to put you some notes out here. So I we're gonna multiply across to get the right column. And then add first two rows to get last two rows. At the end when we go to work this. So when we're talking about liters of alcohol, meaning it's taking the strength of the solution and the liters of the solution to figure out how much of it's the alcohol. So if it says we multiply straight across, then this is the decimal is 0.12 times 12. Multiply across the top. For the second row, I'm going to have 0.20 because we want to write the percent as a decimal, x. And then for the bottom one, we'll have 0.14, 12 plus x. Okay, so that's what I mean by to get the far right column, you multiply straight across. All right, so now we're working with this, and it's saying how many liters for that to happen. And so when you set this thing up, you're going to add the first two rows to get the last row. So we're going to take this one plus this one, and they're going to add together to give us this one. Because we're going to take those solutions and mix them to get our final. So when we write our equation down here, it's going to be 0.12 times 12 plus 0.20 x is equal to the 0.14 times 12 plus x. And that's my comment right there. Okay. So we knew that we took those two solutions, added them together, and we're trying to get the solution that we want at the end. But the question is, well, how much of that 20% solution did we have to put in to make all those things happen? So now we're ready to solve this. And you can see that there is a decimal place in all three of those. So one of the things to get rid of the decimals, I can multiply through by 100 to everything. As long as you do it to one, everything in the problem, you're not changing the value. So that's just gonna, if I move this one two, move this one two, move this one two, multiply everything through by 100, I'm just gonna be working with 12 times 12, 20 times x, 14 times 12 plus x. That's not required, but it's just gonna make those algebra simplified. Now we're solving for x. My left-hand side needs to be simplified. My right-hand side, we're going to distribute 14 times 12 is 168. And then 14 times x is going to be 14x. Left-hand side is good. Right-hand side is good. At this point, we're ready to start solving for x. So we want to move all the x terms to one side. So we're going to subtract 14x from both sides. Here is all section 7.1 practice. Once we get to this point, get 6x by itself, so subtract 144 from both sides. That's going to be what, 24. Divide both sides by 6, and x is equal to 4. So we go back up and we make sure we answer the question. So it says, how many liters of the 20% solution are needed? So we need 4 liters of the 20% solution. Okay. Look at another one like this. A car radiator needs 40% of antifreeze. The radiator holds 20 liters of a 20% solution. How many liters of this should be drained and replaced? So we got a little bit of extra going on here with 100% to get the desired strength. So if you start, we're going to start with our strengths usually, and anything that's listed, we're going to put those, and then the liters of the solution, and then the liters of the chemical, as in what we want. So, car radiator needs 40%. But that's because I know that's what I'm needing, so I just put that last. Now, you don't necessarily have to have it set up exactly this way, but if you know where you're going, you can probably kind of put that last. If you know the stuff that's given, put it first if possible, but if not, you can rearrange afterwards if you need to. All right, then the next thing we say is radiator holds 20 liters of a 20%. So 20 liters of a 20%. How many of this should be drained and replaced? Well, that's still talking about the 20%. So I put 2 of them because one was what we started with, and they're saying, well, how much should be drained and replaced? So it's still talking about the 20%, but one's drained and one's just the given. So 20%, 20 liters of a 20%, but it says how many liters of this should be drained and replaced. So we don't know this, but we know that's what they're asking us about. How many liters should be drained and replaced with the 100%. So what about that 100%? We're replacing it though, right? So if we figure out what the X is, we're going to take the 20% of the X. Let's just pretend at this point we say 5. I take 5 gallons out of the 20%, and it says replace it with the 100%. How many gallons was it? 5. So it's our X. It has to be that same value. Whatever value we're going to take out, we're going to put back in. So not only is that one X, but this one's X because it's the, I'm just going to make a note so that you can kind of follow this later. X that same value. If you're going to drain it and then turn around and replace it, we don't know what that value is just yet, but we do know they're the same. So we're going to let them both be X. And then it says needs 40%. 40%, how much can our radiator hold? We know the percentage we're wanting to get. How much does it hold? 20. It tells us it holds 20. It's holding 20% of a 20. We want to change the solution of it, but the fact that it holds 20, it still holds 20. So we want to know how much of the 40%, but we know it can hold 20. So this one I feel like is a little bit more, it pulls a little bit more. It's not quite as intuitive as in like getting our flow of those. Because we have to think a little bit about the whole draining and putting it back in scenario, and also the quantities that we're starting with and where we're going. So this one's a little more challenging in that sense, but that's why we're going to show you one of these. Now to get my right side, it's looking like we're just going to multiply across like we do once we get those. So 20% is 0.20. Multiply straight across times 20. So to get our right column, we want to multiply. All right, 20. But what do you think we represent when we drain something out? Yes, or it's a negative. It's a negative value because we're taking in the account that we're draining. Actually, let's just highlight that. Draining means we're gonna take it back out. 100%, which is the same thing as move the decimal 2 places, just 1x. Putting that back in, so it's going to be a positive value. And then the last one is 0.40% of a solution. There. So it says a car radiator needs 40% of antifreeze. we're working with 20% and 100%. Like we got to make that combination, the mixture, happen so that at the end of the day, we have a 40% solution that fits in a 20-gallon, 20-liter tank. So we're going to take our point, our right-hand side. We take that original one, the 20%. We're going to drain our next value. And then what do we do after that? Put back in the other value that's with using the 100% solution mixture. And then we're hoping to get our 40% that we're looking for, which is, make sure I have all my decimals in place. Decimal, kept my negative, positive, equal to the right-hand side. Okay, I think we're good. So the setup part's what's new to you today. This next part, 7-1 stuff, is just applying it and solving for x. But the top part, that's really where we got to zone in and focus is on what's going on. Okay. So now here we're going to multiply everything through by 100, just like we did in the previous, so that we can work without these decimals. So hopefully make our calculations a little smoother. Minus 20x, or you could 20x, 100x. So multiply everything by 100. And I just multiplied out all my parentheses. This point, want to make sure we add like terms. So right here is a like term, and here's a like term. So I just want to simplify that, and I'll have 80x on this side. Solve for the variable x. So move the 400. Whatever you do to one side, do to the other. So subtract 400 from both sides. And you're going to get 80x is equal to 400. Divide both sides by 80. Zeros cancel, so 40 divided by 8 is equal to 5 liters. So 5 liters of the 20% solution was drained out, and we put 5 liters of 100 solution back in, so that at the end we have a 40% solution that fills our gradient. So just to recap, we're going to do application problems of solving equations, what you've done. You have some mixture problems, so a couple of interests. Those are pretty basic. The motion ones, basic formulas, plug in, practice rewriting expressions, fairly basic ones like this. And then towards the end, you'll have the challenging ones, which are the mixture problems. And so the rhyme or the reason to these is if you set up a table, try to get all your strengths that are listed, find your knowns, plug them in, figure out your unknown and call it X. The next problem is going to probably have some type of relationship to that unknown, whether it's the same as it or before we added it together. And then to flow with the table, multiply to get the right side. And then usually it's going to be the columns added down to equal the bottom one, if you have your table set up correctly. If not, because sometimes it's not always easy. Like I had a little bit of a template for you, and that made it. But when you start working with yourself, your idea is that you're going there. And here's the one. This one was by far your most challenging one. When you had that 40%, like I put that at the bottom, and maybe as you was reading across, you'd be like, how'd you know to put that at the bottom? Because I knew it was in game. I knew it was where I was going. Because at the end of the day, remember when I set them all equal to that quantity, I know that ahead of time. So, but if I didn't do that and I started working this thing out, like I could always rearrange my table so that I can make it work. But, and the drained is a little bit of a curveball at you because we do put that expression in there, but we have to apply the negative value to it because we're draining it out and putting it back in. So some signs come into play there. Be careful, but this is a template for you to have when you hit that one that's like this, so you should be a little bit more comfortable with it.